Okay. Hey, quiet now. So we're going to have a look at 6. Yes. Yes. Okay. Is this your 100?
Yeah.
Okay, so in number 6, the problem is as follows. You are given a sheet of paper and you must cut a corner out from each corner. And then after you cut the corners out, what you're to do is to fold it up to make an open top box. So if you want to picture it, it's like you fold here, 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 and here, and you fold it up. Oops. So the box gets folded up and it has it's a box, but it has no lid. It's an open top box. And the question is, how much should you cut from each corner so that the box you make has maximum volume? So of course, if you cut off a little piece, the box will be very short and it will not hold much. If you cut off too much, it will be very tall but very skinny, so again it won't hold much. So there's somewhere in between that will have maximum volume. So to start with, we should write down how big each side is. So I'll call the total length L. So if you look carefully, you can see that each side here must be L minus 2x on each side on the base, because if that is L and you cut away 2 x's, you're left with L minus 2x. And how high will the box be? What will be the height of the box? No, using the letters I've given you, it'd be x. Very good. So then, therefore, the volume will equal L minus 2x times L minus 2x times x, which will equal L squared minus 4LX plus 4x squared times x, which will equal 4x cubed minus 4LX squared plus L squared x. So I'll pause there for a minute. Are you writing this down, MB?
No.
Good answer. We'll have you telling the truth by the end of the year, don't worry. Okay, so now you've got a formula for volume. And what's great is that the formula has only one variable in it. The variable is x. So we'll go straight ahead and differentiate. So dv dx, very good, 12x squared minus
8 x.
Yep.
L squared.
No mode 53 is going to help you here. You're going to have to think. So we don't know the number in the middle. Well, we do, but it has an L in it. The number at the end is L squared. Factorizing is possible, but what's the other way we can solve a quadratic? We could use the formula, true, or we could complete the square. So we have a choice, the formula or completing the square. Completing the square, I think, would be a little bit easier. Yes. So firstly, I'll divide everything by 12 to get rid of that. So I have x squared minus 3 over 4 lx plus L squared over 12. Just dividing by 12. Now I can complete the square. So if you recall, it's x minus half of the middle number. So what would that be here? 3/8 L squared. 3 over 8. It's half this number. Remember? Andy? You're talking about this bit at the end?
No. The second line. Yeah.
8 over 12. Sorry, that's not 3/4, that's 2/3, isn't it? Sorry, thank you. 2/3. Oh, that's even better, because half of that would only be 1/3. And then the piece at the end, do you remember what you do? It's this number minus the square of this number. So it's L squared over 12 minus L squared over 9. So you get x minus 1 over 3 L squared plus, sorry, be a minus when you subtract it, minus L squared over 36 equals 0. Thank you. Okay. So we'll take this piece over to the right. We get x minus 1 over 3 L squared equals L squared over 36. Now what do you think we do next? Square root everything. So you get x minus 1 over 3L equals L over 6. And I won't consider the negative answer because it's lengths, so it should be positive. So just take this over to the right. 1/6 of L plus 1/3 of L, so that'd be 5/6. Actually, you know what? I will consider both answers just in case they actually are both positive. So the first possibility is x minus 1 over 3L equals L over 6, or x minus 1 over 3L equals minus L over 6. You have two answers to consider. In this case, if you bring it over to the right, you'd get x equals 1/3 plus a 6. So that's 1/6 plus 2/6. Is it a half? No. Yes, it's a half, isn't it? Yeah. And then this one here, 1/3 minus a 1/6. So 1/3 minus 1/6 is 1/6. If you type it in on your calculator, you should get that. So, in fact, you do get two positive answers here. So we're in the situation where we have two answers, but actually only one of them makes sense, and one of the answers is nonsense. Which is the nonsense answer? Which is the... Why does the half L make no sense? Yeah, if you tear out a half from the one end and from the other end, then there's no paper left. So the only sensible answer is L over 6. Okay? And if you want that as a percentage, so what this answer tells you is you should remove approximately, remove exactly 1/6 from the ends. So with a number example, maybe here, if you got a 60 by 60 piece of paper, you should remove how much from each corner? A 6, which will be 10 centimeters from each corner.
So if we use formula, the x will be 10. If we use formula, not using
The x will be cancelled?
no, we need a text in the formula.
The formula is x equals. Yeah.
Why is it 7 times the answer?
I think it's just a typo. It should have said 6 times. Does it say 7? Yeah.
Why 60?
Oh, just as an example. If you had a 60 by 60 page, you should cut off a 10 by 10 square. Yes, you got that taken down? I've seen this one in the exam. The only difference in the exam is they actually give you a number at the start for the size of the page. So they'd say, you have a piece of paper and the paper is 60 by 60 centimetres. So the exam question would be broken down into parts. So part 1, they would ask you is, how long is each side? So what's the answer? It was L minus 2x, L minus 2x, and x. Part 2, what do you think part 2 would be the question? Find the volume. Yep. Part 3, differentiate the volume. Part 4, find the maximum. And then the last part, part 5, which I haven't done yet, what do you think that would be? What do you think the last part is usually? Second derivative, and then part 5, the second derivative, and then part 6, use the second derivative to show that it's a maximum. So what is the second derivative here? Where's my second derivative? There it is there. So if I go to the side, second derivative, that would equal, it'd be 2x minus 2L over 3. I'll just go to the side for the moment. Right? Yes? Now, what was x in my final answer? L over 6, wasn't it?
Yeah.
So that would be 2L over 6 minus 2L over 3. A sixth, well was that 0, is it? No, that's 1/3. 1/3 minus 2/3. So that's negative then, which is good actually, because negative means maximum. So, that's a full section B question. So some people like this in the exam, some don't.
I don't.
Then my advice to you is don't do it. But if you do like it, do it. Okay, so will I go back to the main one? Yeah? Do you need me to, I'll zoom out a bit. Oops. Okay. So I'll go to the next page then. It's an easy one.
Well, because it's starting with the new chapter.
Huh?
Because it's the beginning of the new chapter.
No, the end. But it's an easy end. I upload it every day to Moodle. Don't worry.
So that I didn't find it.
Yes. Okay. Got that next topic now. Andy? You're distracting your teacher again. Tangents and normals. I'll do 2 examples because I feel 2 is plenty for this. So I give you some function. Let's say y equals x cubed plus x squared plus 1, something like this. And then I give you a point on the graph. Let's say it's the point x equals 1. And my question is, what is the equation of the tangent line? It's not difficult. It's a short question. It's usually a section A question. You start off by saying, firstly, what is the equation of a line? It's y equals mx plus c. Right, now, be cool. Don't be stupid. Just think.
X1.
No. So, how can you find the slope of the tangent? By using
Derivative 1.
derivative once. Yes, very good. So, what's the derivative here? 3x squared plus 2x. But you have to put in x as 1, because that's where it is. So here you'll get 5. So you have y equals 5x plus c. Now, how do you normally find a c?
Find the gradient.
Yes, no, come on, how do you find the c? No. Substitute what, yes? Oh, no, it started off well, but then it got shaky. Substitute a point in to find the c. Remember, this was chapter 1, week 1. Yeah, long time ago. So, what point do we have? What's the x? 1. But do we have the y? No problem, because I can just put that in here. And what's the y? 3. Yeah. No, don't. What do you mean no?
Why it's 3?
I'm Jed. I was talking to Lorraine about this actually, how people have trouble doing things in their head. What's 1 cubed? 1 squared?
1.
And 1 plus 1 plus 1?
3.
Yeah. So now you put this in here to get the c. So you have 3 equals 5 plus c. So what does c equal? Minus 2. And you're done. Y equals 5x minus 2. That's the equation of this line. Okay, I'll give you a minute to write that down. You need to get the point?
Take something or wait for it.
Passport maybe?
Yeah.
Why don't you not do this?
Missing my sister.
You don't miss your maths class for that? Family? You have a lot to learn.
Yeah, I become with it.
Okay, you as soon as you land in London, look at Google, okay? So this is a typical short question in the exam, okay? Because it tests your knowledge on this topic and it doesn't take long to do. So the name of this topic, come on, get out of my way. Go. Say flight now. Yeah. What's this one country? Oh, right, okay. Right. So we have this one here. I don't know. No, it's so funny. We have this one here, tangent, and then the other type is normal. So does anybody? I don't know if I gave you this vocabulary. What does normal mean? Very good. If this is the tangent, the normal is the line that's perpendicular to it. Okay, so I'll do an example with that now. Okay. Let's go with the quadratic this time. Y equals x squared plus x plus 1. Again, we'll make it easy. And let's say x equals, again, let's make it easy, 1. But this time, I don't want the tangent. Instead, I want this line, which is the normal. And that is perpendicular to the tangent. Yes?
How it can be perpendicular and this line is not straight?
This line is perpendicular to the tangent line. That's the definition. The normal is the line that is perpendicular to the tangent. So it makes it 90 degrees with the tangent line here. Yeah? No?
So is this line exist or here?
Well, we are trying to find the equation of this line, this normal line. I just showed you how to find the equation of this line. Now I'm going to show you how to do it for this one. Remarkably similar. So what's the equation of a line? Y equals mx plus c. Now, the derivative gives you the slope of the tangent. So what's the derivative here? 2x plus 1. And what's the x? 1. So this here is 3. That is the tangent, but we want the normal, which is perpendicular. So if it is perpendicular, it will be, yes, minus 1 over 3, x plus c. How do you find the c? You use a point. What point do we use? 1, and what's the y?
0.
No, 3. Because you can get it from this one here. So we have 3 equals minus 1 over 3 plus c. So then c is 10 over 3. So we have the answer. Y equals minus 1 over 3x plus 10 over 3. A very, very, very common mistake in the exam is the question asks for the normal and students give the tangent, or vice versa. Wrote this down? Okay. So I'll tell you which ones to start at, and I'd like to see as you're working on it your attempt at the last homework, which was the 2 questions. So there's a good chance that you'll get these done now. So let's see which ones. Page 87, the one that you have open in front of you, like I asked you to at the start. So questions 1 to 6, you can start them now, and there's a good chance that you get all 6 of them finished before the end. I'll leave this up here, I just need to stop.